Next, in section 3.4, we have the derivative of the natural log function. And that's the only new rule here, no new vocabulary. So let's begin. Now that we know the derivative of e to the x, it becomes relatively easy to find the derivative of its inverse function, the natural log of x. And that's a good time to remind everyone out there that e to the x and the natural log of x are inverses. And that's going to come in handy here in just the second line of work. So we want to find the derivative of the natural log of x. Let's define that to be a function equal to y. So y equals natural log of x. Then, since e to the x and natural log x are inverses, we have a direct result of the second line, that e to the power of y is equal to x. And you can grab that by taking e to the power of both sides of that first line. So we're going to differentiate this second line with respect to x. We choose to do that simply because we know how to find the derivative of e to a power. So let's begin there. The derivative with respect to x of e to the y will be found with implicit differentiation. It's going to be itself, e to the y, times dy dx by the chain rule. And this is going to be equal to, on the right side, simply a 1. Next, we continue to solve for dy dx by dividing both sides of this equation by e to the y. And that leaves us with a statement that dy dx is equal to 1 over e to the y. But if you recall from our second line of work, we know that e to the y could be replaced by x. So now we have finally dy dx is equal to 1 over x. And that's our rule. We can state this more formally, that d dx of the function natural log of x is equal to simply 1 over x. Here it is in all its glory. The derivative of the natural logarithm function natural log x is 1 over x. And then by the chain rule, if u is a differentiable function of x and u is positive, the derivative with respect to x of the natural log of u is 1 over u du dx. Or some students like to remember this as u prime over u. Let's see this in action. Here's an example. A line with slope m passes through the origin and is tangent to the graph of y equals the natural log of x. What is the value of m? I think this question becomes a little trickier than what it seems on the surface, and it's simply because of our lack of information. So what we know for sure is we have a function y equals natural log of x, and I think we can work with that by doing a little bit of a sketch. So here's the natural log of x function. Next, we know there's a tangent line and it passes through the origin. So the origin is 0, 0. It's also going to be tangent to this graph somewhere. So let's sketch in a little tangent line. We know that this is the point 0, 0. And let's label this second point out on the graph of natural log of x. Let's say its x value is some number a. And then that means its y value is natural log of a. So this point then is a comma natural log of a. We also know that the slope of this line is called m, and we're trying to find the value of m. So we can get a little bit more specific about that slope by differentiating the function. We know then that the derivative of that function will give us the slope of the tangent line. So let's find dy dx. So dy dx of the natural logarithm function is just 1 over x. And if we evaluate that at our x value, x equals a, we're going to have 1 over a. So let's set up a little bit of a slope equation. We want to define the slope between the point 0, 0 and the point a comma natural log of a. We know that slope should be equal to 1 over a. So let's set it up. We have a y value, natural log of a, minus a y value, 0. Then we have an x value a minus an x value of the origin point 0. This should be equal to 1 over a. And then that gives us the natural log of a over a equals 1 over a. And we're trying to solve then here for a. So let's go forward with some cross multiplication. We have the natural log of a times a. And then this is equal to a. All right, let's continue to solve for a. The next thing we can do is divide both sides by a, and that gives us the natural log of a equals 1. Finally, then, what we want to do is take e to the power of both sides. We'll undo that natural log and solve for a. So this will give us a is equal to e to the power of 1, or just e. So finally then, what is the value of m? Well, we know the slope here at this point is 1 over a, and we also know that a is equal to e, so m in this case is 1 over e. And we have an answer to this question, and we're going to leave exercise 31 to you, the student and viewer of this video, and that's the derivative of the natural logarithm function.